March 6, 1944. 28,000 feet above Berlin, Hauptmann Klaus Buerschgens pushed his Messerschmitt BF 109 G6 into a climbing turn, tracking an American bomber formation through the glare of midday sun. The Reich capital lay below, shrouded in industrial haze and the smoke of anti-aircraft batteries unleashing desperate curtains of flak against the largest daylight raid the city had yet witnessed. 660 bombers had penetrated German airspace, their contrails etching white lines across the winter sky like the fingers of an approaching hand. But it was not the bombers that commanded Buerschgens' attention in those critical seconds. It was the fighters. Sleek, silver aircraft with distinctive bubble canopies and invasion stripes were weaving protective patterns through the bomber stream, their presence over Berlin representing an impossibility that contradicted everything Luftwaffe intelligence had assured German pilots about American capabilities. These were single-engine fighters operating at full combat effectiveness over the German capital, more than 500 miles from their bases in England. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Engaging aggressively with no apparent concern for fuel reserves or the long journey home. The aircraft were North American P-51 Mustangs, and their presence over Berlin on this March morning would shatter the fundamental assumptions upon which German air defense strategy had been constructed. The Luftwaffe had prepared to fight American bombers. They had trained tactics for attacking closely packed formations, developed specialized armament configurations, and accepted the necessary casualties as the price of defending the Reich. What they had not prepared for, what their intelligence services had assured them was technically impossible, was facing American escort fighters with sufficient range to accompany those bombers throughout the entire mission, from English airfields to Berlin and back. The strategic calculus of the air war over Europe had rested on a single, seemingly immutable fact. Fighter aircraft, constrained by fuel capacity and the inefficiencies of piston engines, could not fly the distances required for deep penetration missions into German territory while maintaining combat capability. The laws of physics and engineering appeared to dictate that bombers venturing beyond a certain point would be forced to proceed without fighter protection, leaving them vulnerable to concentrated German interceptor attacks. This calculation had shaped German defensive doctrine throughout 1943. The Luftwaffe accepted losses during the initial stages of American raids, when short-range fighters like the Republic P-47 Thunderbolt could provide cover. But German interceptor units knew that somewhere over Belgium or the Netherlands, those escorts would reach their fuel limits and turn back. Beyond that invisible line, the bombers would be alone, and German fighters could attack with relative impunity, accepting casualties from bomber defensive fire as necessary, but avoiding the far more dangerous threat of enemy fighters. The Americans had tested this defensive barrier repeatedly during the autumn of 1943. On October 14th, a force of 291 B-17 flying fortresses attacked the ball-bearing plants at Schweinfurt in Bavaria, penetrating deep into southern Germany far beyond the range of available fighter escorts. The Luftwaffe had launched wave after wave of interceptors against the unescorted formations, maintaining attacks throughout the bombers' penetration and withdrawal. The results validated German defensive assumptions with devastating clarity. The Americans lost 60 bombers that day, shot down by German fighters who could focus entirely on attacking the formations without the distraction or danger of hostile fighters. More than 600 American airmen died or were captured. The losses were unsustainable. The Americans called it Black Thursday. The 8th Air Force suspended deep penetration missions for months afterward, unable to continue suffering such catastrophic attrition rates. The Schweinfurt raid had appeared to prove that unescorted strategic bombing deep into Germany was operationally impossible. The bomber formations, despite their defensive armament and tactical formations, could not survive concentrated fighter attacks without escort protection. Yet extending fighter escort to targets like Schweinfurt or Berlin seemed equally impossible given the fundamental constraints of fighter aircraft range. German technical intelligence had analyzed captured American fighters systematically. The P-47 Thunderbolt, which equipped most American fighter groups during 1943, carried 150 gallons of internal fuel. Its massive Pratt & Whitney radial engine consumed fuel at rates exceeding 100 gallons per hour during combat operations. Even at economical cruise settings, the aircraft could fly for perhaps 2.5 hours before exhausting its fuel supply. This gave it an operational radius of approximately 200 miles under combat conditions, sufficient to escort bombers to targets in occupied France, but wholly inadequate for missions into Germany itself. The Lockheed P-38 Lightning, a twin-engine design, carried more fuel and could fly farther. German evaluation of captured examples indicated the type could escort bombers perhaps as far as Frankfurt or Stuttgart. But the P-38 suffered performance limitations at high altitude, where its turbocharged engines proved temperamental in the cold, thin air above 20,000 feet. The Luftwaffe had developed tactics specifically to exploit this weakness, engaging the twin-engine fighters at altitudes where German single-engine fighters maintained superior performance. These assessments had created a defensive strategy built on the certainty that American bombers attacking targets in eastern Germany or the Reich's industrial heartland would be forced to fly significant portions of their missions without fighter protection. German interceptor units positioned themselves to exploit this vulnerability, concentrating attacks during the portions of American missions where escorts had reached their limits and turned back. The strategy had worked, inflicting losses that forced the Americans to curtail their deep penetration missions during the latter months of 1943. The German High Command believed they had identified a fundamental weakness in American strategic bombing doctrine, a physical limitation that could not be overcome without revolutionary changes in aircraft design or basing locations that would require months or years to implement. Intelligence reports during early 1944 had noted the appearance of a new American fighter type, the P-51 Mustang, but initial assessments treated it as another short-range tactical fighter, similar to the P-47. Luftwaffe intelligence knew the Mustang mounted a British Rolls-Royce Merlin engine, built under license by Packard in the United States, but this was viewed primarily as an improvement in high-altitude performance rather than a revolutionary increase in range capability. Combat encounters with Mustangs during January and February of 1944 had been limited. The aircraft appeared over France and the Low Countries, but these sightings occurred within the expected range of single-engine fighters operating from England. Reports noted the Mustang's excellent performance and maneuverability, its speed advantage over existing Luftwaffe types, and its superior high-altitude capabilities. But these were seen as incremental improvements, not fundamental changes to the strategic situation. The possibility that single-engine fighters might escort bombers all the way to Berlin seemed to violate basic engineering principles. The distance from American bases in England to Berlin measured approximately 560 miles one way. A round trip, including time over target and combat maneuvering, required approximately 1,100 miles of range. German calculations indicated this was simply beyond the capability of single-engine fighters, given the fuel capacity constraints imposed by airframe size and the fuel consumption characteristics of high-performance engines. Then came March 4, 1944. A small force of American bombers attacked Berlin, and P-51 Mustangs accompanied them. Weather and communication problems limited the raid's effectiveness, with only 32 bombers reaching the target area. But German interceptor pilots encountered American single-engine fighters over the capital, fought them in extended engagements, and watched those same fighters withdraw westward, apparently returning to England. Initial reports were met with skepticism at Luftwaffe headquarters. Perhaps the Mustangs had landed at Soviet airfields in the east, flying shuttle missions that would allow them to extend their range by not returning to England. Perhaps they had somehow refueled in flight, though no evidence of such capability had been observed. Perhaps the reports were simply mistakes, misidentifications in the chaos of combat. 2 days later, on March 6th, the Americans returned with a massive force. Over 600 bombers attacked Berlin in broad daylight, and this time there was no mistaking the escort fighters' presence or capabilities. More than 150 P-51 Mustangs accompanied the bombers, operating at full combat capability over the German capital, engaging in prolonged dogfights and demonstrating no apparent concern about fuel reserves for the return journey. General Major Adolf Galland, General der Jagdflieger, and one of Germany's most experienced fighter aces with more than 100 victories, had taken to the air that day despite his administrative position. He encountered the American fighters personally, engaging them over Berlin in combat that immediately revealed the P-51's superior performance characteristics at high altitude. But more significant than the aircraft's performance was its mere presence. Galland's combat assessment, submitted through official channels immediately after landing, noted that American fighters were operating at full combat effectiveness over Berlin, with no observable fuel conservation behavior. They were not flying at the absolute limits of their range, nursing every drop of fuel to make the return journey. They had reserves. They had the capability to engage in extended combat and still return safely to England. This contradicted everything Luftwaffe intelligence believed about American fighter capabilities. The fundamental premise of German air defense strategy, the assumption that physics and engineering imposed inviolable range limitations on single-engine fighters, had been shattered. American bombers could now strike any target in Germany with fighter escort throughout the entire mission. The invisible defensive barrier that had protected German industry and cities from sustained daylight bombing no longer existed. Buerschgens, pressing his attack through the American fighter screen on March 6, experienced this new reality directly. The Mustangs maintained aggressive coverage of the bomber stream, forcing German interceptors to fight through the escort screen before reaching the vulnerable heavy bombers. Any German pilot who became separated from his formation or focused too long on a bombing run found himself under immediate attack from American fighters whose performance at altitude exceeded the Messerschmitt 109's capabilities. The tactical situation had inverted. German fighters now had to fight their way through superior enemy fighters just to reach the bombers. And those enemy fighters, rather than being worn down by the long mission or forced to conserve fuel, seemed capable of sustaining combat operations indefinitely over German territory. The Luftwaffe's advantage of fighting over friendly territory, where damaged aircraft could land and pilots who bailed out could return to their units, had been neutralized by the Americans' ability to maintain fighter superiority over the battlefield. The March 6 mission cost the Americans 69 bombers, but this loss rate, though significant, was sustainable for an air force supported by vast American industrial production. More critically, the escorting fighters had prevented far heavier losses. The Luftwaffe's ability to inflict crippling attrition on unescorted bomber formations, the tactical success that had forced the Americans to suspend deep penetration missions after Schweinfurt, had been eliminated. German pilots returning from the mission filed combat reports that reflected shock and confusion. Many expressed disbelief that single-engine fighters had operated so far from their bases. Some suggested the Americans must have developed new fuel technologies or secret weapons. Others noted the Mustang's superior speed and climb rate, their excellent maneuverability, and their apparent numerical advantage as American fighter groups concentrated over the target area. Luftwaffe intelligence scrambled to understand what had changed. Had the Americans developed revolutionary new engine technology? Had they discovered some way to dramatically improve fuel efficiency? Were they using aerial refueling despite no evidence of such operations? The questions multiplied as additional escort missions to Berlin and other distant targets continued throughout March and April, each one demonstrating that the March 6 mission had not been an anomaly or special effort, but rather represented a permanent new capability. The answer, when German technical staff finally pieced it together through systematic analysis of captured aircraft, combat debris, and intelligence reports, proved simultaneously simple and devastating. The Americans had not developed revolutionary technologies or secret weapons. They had solved the escort fighter problem through methodical engineering, industrial efficiency, and the same overwhelming material advantages that characterized every aspect of the Allied war effort. The P-51 Mustang carried 184 gallons of fuel in wing tanks, plus an 85-gallon fuselage tank positioned behind the cockpit. This internal capacity of 269 gallons, combined with the Merlin engine's relatively efficient fuel consumption at cruise power settings, gave the aircraft approximately 1,140 miles of maximum range. This was just barely sufficient to reach Berlin from England and return, but only if the pilot flew at economical cruise settings throughout the mission, avoided combat entirely, and accepted essentially zero fuel reserves for emergencies. Combat operations consumed fuel at much higher rates. Full power settings during dogfights burned fuel at rates exceeding 100 gallons per hour. 20 minutes of combat maneuvering could exhaust 50 gallons or more. Yet American pilots over Berlin were engaging in prolonged battles, sometimes fighting for 15 or 20 minutes before disengaging, and still returning safely to England. The internal fuel capacity alone could not explain this capability. The critical factor proved to be something the Germans had used themselves since the Battle of Britain, but had never implemented on the scale and, with the efficiency, the Americans were demonstrating. Drop tanks, external fuel tanks that could be carried under the wings, extending range by providing additional fuel, then jettisoned before combat to reduce weight and drag. German fighters had used drop tanks for years. The Messerschmitt BF 109 regularly carried a 300-litre drop tank for extended range missions. The Focke-Wulf 190 could carry similar external tanks. This was standard practice across all air forces, an obvious solution to the range problem that involved obvious trade-offs. Drop tanks added weight and drag, reducing performance and maneuverability. They had to be jettisoned before combat, and once released, that fuel capacity was permanently lost. The tanks themselves represented a manufacturing burden, requiring materials, production capacity, and logistics support. What differed was not the concept, but the scale of implementation. The Americans were producing drop tanks in quantities that allowed every fighter on every mission to carry them. Not just occasional special missions or small formations, but entire fighter groups, multiple times per week, with enough production capacity to sustain this tempo indefinitely. The P-51 Mustang's wing hardpoints were designed to accommodate drop tanks with standardized fittings. The most common configuration paired two 108-gallon tanks, one under each wing. This external fuel capacity added 216 gallons to the aircraft's fuel supply, bringing total capacity to 485 gallons. With this fuel load, the Mustang could fly for approximately 6.5 to 7 hours at cruise settings. This translated to a combat radius exceeding 700 miles when accounting for takeoff, climb, time over target, and fuel reserves for combat operations. Berlin, lying 560 miles from English bases, was well within this operational envelope, with ample reserves for extended combat. The external tanks would be jettisoned when enemy fighters were encountered or before entering combat maneuvering. Standard procedure called for fighters to climb to altitude while running primarily on external tank fuel, consuming the drop tank capacity during the cruise to the target area. Once over hostile territory, or when combat appeared imminent, the external tanks would be released. From that point forward, the aircraft operated on internal fuel alone, but having already covered much of the distance to target, the internal capacity was sufficient for combat operations and the return journey. This was not complicated. The tactical employment was straightforward and followed obvious principles. What was remarkable was the industrial capacity required to support such operations on the scale the Americans were conducting them. Each mission to Berlin required drop tanks for every escorting fighter, with more than 150 Mustangs participating in the March 6th raid. That meant more than 300 drop tanks consumed in a single day's operations for one fighter type supporting one mission. The Americans were flying multiple missions per week. Multiple fighter groups required tanks. The P-47 Thunderbolt groups also used drop tanks to extend their range. The P-38 Lightning groups employed them as well. The total consumption of drop tanks across all American fighter operations in the European theater measured in the thousands per week. This volume of production represented an industrial capacity that Germany could not match. German factories struggled to produce sufficient drop tanks for their own fighter forces' needs. Every tank required aluminum or steel, materials that were desperately needed for airframe production, ammunition, vehicles, and thousands of other military requirements. German industry operated under constant resource constraints, forced to make impossible choices about material allocation. The Americans, by contrast, appeared to have eliminated resource constraints as a limiting factor in their tactical planning. They used drop tanks not sparingly as a special measure for critical missions, but routinely as standard operating procedure across their entire fighter force. The tanks were manufactured in quantities that allowed them. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. To be treated as expendable items, single-use containers that would be dropped over enemy territory and never recovered. This approach to warfare, where material abundance enabled tactical flexibility that constrained opponents could not match, characterized the broader strategic situation Germany faced by early 1944. The ability to produce drop tanks in such quantities was merely one visible manifestation of industrial capabilities that extended across every dimension of military power. American factories were producing aircraft faster than Germany could destroy them. Pilot training programs were graduating aircrew faster than combat could attrit them. Fuel supplies, though requiring complex logistics to transport across the Atlantic, remained adequate to support intensive operations. Germany faced the opposite situation in every category. Aircraft production struggled to replace combat losses, despite heroic efforts by workers and managers. Pilot training programs had been shortened repeatedly, forced to graduate inadequately prepared pilots to fill urgent needs at operational units. Fuel supplies, dependent on synthetic production facilities that were themselves becoming targets for Allied bombing, grew increasingly inadequate to support intensive defensive operations. The appearance of P-51 Mustangs over Berlin, accompanied by hundreds of expendable drop tanks that enabled their presence, represented a turning point where the air war's fundamental mathematics shifted irreversibly against Germany. The Luftwaffe could no longer inflict unsustainable losses on American bomber formations. The defensive strategy built on forcing bombers to penetrate beyond fighter escort range had collapsed. Every target in Germany was now vulnerable to sustained daylight attack, with fighter protection throughout the mission. Buerschgens survived the March 6 engagement, landing his damaged Messerschmitt at an emergency field near Potsdam with nearly empty fuel tanks and ammunition expended. His combat report, filed that evening, noted the superior performance of American escort fighters and their apparently unlimited fuel reserves. He could not explain how single-engine fighters were operating over Berlin. He could only report what he had observed and survived. Similar reports arrived from across the Luftwaffe's fighter units throughout March and April, as escort missions to Berlin became routine rather than exceptional. German pilots faced a new operational reality where American fighters would be present throughout every mission, where German interceptors had to fight through superior escort screens just to reach the bombers, and where the tactical advantages German pilots had exploited during 1943 no longer existed. The systematic examination of captured aircraft and recovered drop tanks would eventually reveal the technical details behind this capability. But for German pilots fighting over the Reich during the spring and summer of 1944, the technical explanations mattered less than the operational reality they faced in combat. American bombers would continue attacking German industry and cities with fighter protection that could not be overcome by existing German capabilities. The belief that physics and engineering imposed inviolable limits on fighter range, the assumption that deep penetration missions would always leave bombers vulnerable during portions of their missions, had been shattered by American engineering and industrial capacity working in combination. The P-51 Mustang was an excellent aircraft, but its decisiveness stemmed not just from design quality, but from the industrial system that could produce it in quantities, support it with adequate fuel supplies, equip it with expendable drop tanks manufactured by the thousands, and sustain these operations indefinitely, regardless of losses. German technical staff, examining captured examples and crashed debris from the March missions, worked to understand precisely how the Americans had achieved this capability. Their analysis would reveal details that were simultaneously illuminating and devastating, demonstrating not just technical solutions, but fundamental disparities in industrial capacity that could not be overcome through tactical brilliance or individual courage. The war in the air had entered a new phase, one that would end 14 months later with Germany's complete defeat, a defeat that was already visible in the contrails of American fighters over Berlin in March 1944. The search for physical evidence began within days of the March 6 mission. Luftwaffe intelligence officers plotted likely jettison points based on engagement locations reported by German pilots. Drop tanks would typically be released when enemy fighters were encountered, as the external stores reduced maneuverability and speed during combat. The Americans had engaged German interceptors primarily over Berlin and the approaches to the capital, suggesting drop tanks would be found in the countryside northeast and northwest of the city. Search teams composed of Wehrmacht personnel, Luftwaffe ground staff, and Hitler Youth volunteers spread across the region, looking for any debris from the air battles. The recovery efforts proceeded systematically, with teams assigned to specific grid coordinates and instructed to report any findings immediately to intelligence officers coordinating the search from Luftwaffe headquarters. Within 3 days, several objects were recovered from fields and forests surrounding Berlin. Most arrived at testing facilities in fragmentary condition, crushed on impact, or damaged during the fall from altitude. Drop tanks fell differently than aircraft wreckage. Without wings or control surfaces to slow their descent, they plummeted rapidly, often tumbling and striking the ground with considerable force. Many examples shattered on impact, particularly those that struck frozen ground or encountered trees during their descent. But 2 examples reached Recklinlers airfield in relatively intact condition, having landed in soft agricultural soil or winter wheat fields that cushioned their impact. These recovered tanks would revolutionize German understanding of American industrial methods and reveal the true scale of material disparity between the opposing forces. The captured drop tanks were cylindrical, measuring approximately 108 inches in length with a diameter of roughly 22 inches at the widest point. German engineers calculated that each tank held approximately 108 US gallons, equivalent to roughly 400 liters in German measurements. 2 such tanks would provide 216 additional gallons of fuel, extending the P-51's total fuel capacity to 485 gallons when combined with the aircraft's internal tanks. With this fuel load, a Mustang could fly for approximately 6.5 to 7 hours at economical cruise settings. Accounting for takeoff, climb to altitude, combat operations, and necessary reserves, this translated to an operational combat radius exceeding 700 miles. Berlin lay well within this envelope with substantial margins for contingencies and extended combat. The calculations explained what German pilots had observed over the capital. American fighters were not operating at the absolute limits of their range. They possessed reserves adequate for prolonged combat operations and safe return to England. The mystery of how single-engine fighters reached Berlin had been solved through systematic analysis and captured hardware. But solving the mystery of range revealed a far more troubling question. The technical solution of using drop tanks was straightforward and obvious. German fighters employed the same principle. What was remarkable, what caused profound unease among German technical staff, examining the recovered tanks, was not the concept but the execution and the implications for industrial capacity. German engineers expected the captured drop tanks to be constructed from aluminum or steel, standard aircraft materials that required significant industrial resources to produce. Drop tanks represented a manufacturing burden for German industry, consuming scarce metals, requiring specialized tooling, and demanding production capacity that was needed for countless other military requirements. This resource constraint limited how many tanks could be produced, forcing German commanders to allocate them carefully and use them sparingly. The American tanks were made from paper, not metaphorically, not as an exaggeration or simplification. The external fuel tanks that enabled P-51 Mustangs to reach Berlin and fundamentally altered the strategic balance of the air war over Europe were constructed from laminated layers of kraft paper, impregnated with glue, and formed into cylindrical shapes through a molding process. The discovery stunned German technical staff. Paper tanks seemed absurd, a desperate measure that implied severe material shortages or industrial inadequacy. Paper burned. Paper dissolved in water, Paper lacked the strength and durability required for aviation equipment subjected to extreme conditions. That the Americans would use such materials suggested either remarkable innovation or desperate improvisation, born from the same resource constraints that plagued German industry. Detailed examination revealed the truth was far more sophisticated and disturbing than either extreme suggested. The American tanks were not crude improvisations, but carefully engineered products manufactured through systematic industrial processes, optimized for mass production. The tank construction employed layers of heavy craft paper, each approximately 0.01 inches thick, laminated together with phenolic resin adhesive. The lamination process created a composite material with structural properties adequate for the specific application. Multiple layers built up wall thickness of approximately half an inch, providing sufficient strength to withstand fuel pressure, aerodynamic loads during flight, and the thermal expansion and contraction encountered during operations. The interior surface received a coating of synthetic resin that rendered it fuel-resistant and prevented the paper from absorbing aviation gasoline. This coating was critical, as unprotected paper would quickly degrade when exposed to petroleum products. The resin barrier maintained structural integrity during the tank's operational life, which needed to last only for a single mission. Fittings for fuel lines and mounting hardware were integrated during the molding process. Metal reinforcement rings at attachment points distributed loads and prevented the paper structure from tearing under the stresses of flight. The engineering was competent and appropriate for a single-use item designed to be jettisoned over enemy territory after its fuel was consumed. German engineers tested the captured tanks systematically. They pressurized them to verify structural integrity. They filled them with aviation fuel and monitored for leaks or degradation. They examined the construction methods to understand the manufacturing process. The tanks performed adequately for their intended purpose. They were not inferior substitutes forced by material shortages. They were purpose-designed solutions optimized for specific requirements. This realization proved more troubling than discovering revolutionary technology would have been. Revolutionary technology could be countered through research and development. Advanced weapons could be met with equally advanced countermeasures. But what the paper drop tanks revealed was not a technical breakthrough but an industrial philosophy and material abundance that Germany could not hope to match. The Americans were using paper for drop tanks not because they lacked aluminum or steel, but because using paper was more efficient. It preserved critical metals for applications where they were actually necessary, like airframes, engines, and weapons. It enabled production rates that would be impossible if tanks required scarce metallic materials. It demonstrated an approach to manufacturing that optimized for overall efficiency rather than making desperate substitutions to work around critical shortages. German industry, in 1944, operated under constantly worsening resource constraints. Every ton of aluminum had to be allocated carefully among competing requirements. Aircraft production, ammunition manufacturing, vehicle construction, and countless other military needs all demanded materials that were increasingly scarce. Decisions about resource allocation represented brutal choices between essential requirements, with every selection meaning something else would go without. The Americans appeared to have eliminated resource constraints as limiting factors in their tactical planning. They consumed drop tanks by the thousands per week, treating them as expendable items that could be scattered across enemy territory without concern for recovery or reuse. This approach to warfare, where material abundance enabled tactical flexibility that resource-constrained opponents could not match, revealed fundamental disparities that extended far beyond the specific question of fighter range. Reports from German agents and intelligence sources confirmed the scale of American production. Factories across the United States were manufacturing paper drop tanks in quantities that seemed impossible. Multiple manufacturers produced them using similar designs and standardized fittings. Production was measured not in hundreds per month but thousands per week. The logistics system transported them across the Atlantic, distributed them to fighter bases across England, and maintained supply levels adequate to support intensive operations indefinitely. This was not desperation or improvisation. This was industrial capacity applied with systematic efficiency, leveraging America's vast manufacturing infrastructure, abundant raw materials, and sophisticated logistics networks to solve tactical problems through overwhelming material superiority. German technical staff compiled detailed reports documenting their findings. These reports circulated through Luftwaffe intelligence channels, informing commanders and operational planners about American capabilities. The reports confirmed that single-engine fighters could now escort bombers throughout missions to any target in Germany. They explained the technical methods enabling this capability. They provided accurate assessments of American industrial capacity based on observed production rates and deployment patterns. But understanding enemy capabilities did not provide the means to counter them. German industry could not produce drop tanks on comparable scales. Even if manufacturing methods could be copied, the raw materials required, the production capacity needed, and the logistics systems necessary to distribute and employ tanks on American scales were simply unavailable to Germany in 1944. The Luftwaffe attempted to adapt tactically to the new operational environment. Fighter units developed new attack methods designed to penetrate escort screens more effectively. Specialized, heavily armed interceptors focused on bomber destruction, while lighter fighters engaged escorts. Coordination between ground controllers and airborne units improved, attempting to mass German fighters at critical points, where local numerical superiority might overcome American advantages. These tactical adjustments achieved occasional successes. German pilots remained skilled and courageous, achieving impressive victories against individual formations when conditions favored the defenders. But tactical excellence could not overcome strategic realities. The Americans could sustain their losses through replacement production. The Luftwaffe could not. American pilot training programs continued producing qualified aircrew. German training had been shortened repeatedly, graduating inadequately prepared pilots to fill desperate needs. American fuel supplies, though requiring complex logistics, remained adequate. German synthetic fuel production faced increasing disruption from Allied bombing. The air war during the spring and summer of 1944 became a grinding campaign of attrition that Germany was losing. The ability of P-51 Mustangs to escort bombers throughout their missions eliminated the one tactical advantage German fighters had exploited during 1943, the ability to attack formations beyond escort range, where bomber defensive fire alone provided protection. Now, every mission featured fighters capable of engaging German interceptors throughout the entire operation. American numerical advantages compounded over time, as German losses exceeded replacement capacity, while American losses remained within sustainable limits. The quality differential widened, as experienced German pilots were killed faster than replacements could gain proficiency, while American pilots accumulated experience and confidence. The appearance of long-range escort fighters equipped with paper drop tanks manufactured by the thousands represented not a single decisive battle, but a fundamental shift in operational mathematics that made German defeat inevitable, through cumulative attrition. The systematic bombing of German industry, transportation networks, and fuel production facilities could proceed with losses that, while still significant, were sustainable for an industrial power with America's production capacity. By late 1944, the Luftwaffe's effectiveness had deteriorated catastrophically. Fuel shortages grounded aircraft. Pilot losses could not be replaced. Facilities suffered repeated bombing. The infrastructure supporting military operations collapsed under sustained attack. These outcomes resulted from many factors operating over months and years, but the ability to escort bombers throughout their missions, made possible by fighters like the P-51 carrying paper drop tanks, it was among the decisive elements enabling the systematic destruction of German military capabilities. The war ended in May 1945. The Luftwaffe that had begun the war as one of the world's most formidable air forces had been reduced to scattered remnants, unable to contest Allied air superiority or protect German territory from systematic bombing. The technical superiority German pilots had enjoyed during the war's early years had been overcome by American industrial capacity, producing aircraft in overwhelming numbers, training pilots faster than combat could eliminate them, and supporting operations with logistics systems that German industry could not match. The captured paper drop tanks, preserved in technical archives and later discovered by historians, serve as tangible evidence of the industrial disparities that determined the war's outcome. They represent not a single technological breakthrough, but an approach to warfare where material abundance enabled tactical flexibility and strategic options that resource-constrained opponents could not hope to counter. The tanks themselves were simple devices, cylindrical containers of glued paper designed to carry fuel for a few hours before being discarded. Their significance lies not in technical sophistication, but in what their existence revealed about American industrial capacity and the fundamental imbalance of material resources that shaped the conflict's outcome. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.